Na, 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 na. Na, 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 na. Na, 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 na. Na, na. సో మనం ఈ రోజు ఏం చేద్దాం? ఇప్పుడు ఇది మ్యాథ్‌లాబ్. Okay, this is the MATLAB. So this one is called the director. Okay, so here we can see the files. So now I'm going to show the one optimization. Okay, so how to write this optimization code? This optimization code is available on MATLAB file exchange. Okay, so if you go to the MATLAB file exchange, okay, just click on here MATLAB column. Okay, so MATLAB file exchange you can get. Okay, suppose if you want to get the one algorithm, suppose I wanted to get the PSO algorithm. Okay, PSO algorithm MATLAB file exchange file. Okay, so you need to download the MATLAB file. Okay, so like this here, there is particle form optimization algorithm. So it will like this will come. So in this way, so here is a particle form optimization code is there. So you can see here the code. So go to file. Okay, so whatever the file is there, you can see here. So this file is this we have. So PSO file. So how many members download? So you can see this is the 2015 file. So you can see what are the files inside. Just click. One is main. Main file will be there. For this main file, so we need to write that. Okay, this is the another PSO, that is algorithm file. This the other supporting files will be there. Okay, so similar way, so I have downloaded the ARO optimization. Okay, so ARO optimization tool, that is artificial rabbit algorithm I have downloaded. Okay, so this is the my plan I have considered. Okay, so just I will show the one example. Okay, this is the one plant I have taken. So this will be loading. So due to the less RAM size, it will take time to loading. So here we can until we can see the okay. So let's see the full length. Okay. So go to the home here layout, two column layout will be there. We can check here. Okay, until it will open. Let's see. Here we can have this MATLAB file is opening. Just now we'll go to discuss. So this is a full screen view place like this editor. So here we can see the code clearly. So this is our live file. Okay, so we have the two types of file. One is file. Okay, another is mat file itself. Okay, so that will run as a totally. This is the live file. Whatever we'll done here, it will show us in the right side. Okay, so ARO is nothing but artificial rabbit algorithm. Okay, so here is the how much I given. This is the here is the model name. Okay, whatever the file name is it, that is the file name we have given. Next, this is the stop time. Okay, how much simulate how time is required. Okay, and this one is the parallel. Okay, so parallel running we need to get. Okay, this is the number of population, maximum duration, and so number of variables. Okay, so this is a lower bound, upper bound. So tick tock is means how much time is left. Okay, so how much time it will be there now. So this will be gives the this symbol tick tock. If you give means that will give the how much time is taken. Next here, so best ARO, cost ARO, carb ARO. Okay, for this one, so we are taking. So this is a run. So we are running the algorithm with the model and stop time, number of operation and maximum iteration, lower bound, upper bound, and dimension is nothing but number of variables. How many variables? So here having the four variables I have taken. So here based on that, we need to run. So after running that, we will show the f print means. So whatever the print is there, that is arrow cost is there and time, how much time is taken. that will be displayed here. And this is the figure. So if the plot curve is there, so convergence plot it will show. So number of iteration versus cost function. So cost function should be decreasing in this manner. Okay, that will display. So this is the function for optimization. So here optimization function is there. So here this is the control, right? And here is our cost function. So cost function mostly we need to write our based on the which model we are taking. So which model means here I will show you. So here is our plant is there. Okay. So one plant I have taken. So that is our plant. Okay. So here one plant I have taken. Okay. I want. So here is our transfer function is there, and due to the FOPDT model I have considered. Okay. So FOPDT model I consider. So this numerator and denominator values we need to give. So we need to give the numerator and denominator values, and this the FOPD, this the delay will be there. Okay. So here is the step input and PID controller, and here is the I have the two loops. Okay. So I am taking the input and the output. Okay. There's the two inputs are there and two output for each individual loop is there that I am calculating. Okay. And here these are the transfer functions are there. Okay, here is the error signal. So all are placed in a time series mode. Okay, so this time series mode I consider, and here is the clock which is having running in it. So here whatever the time is that I am limited in the code. So in the code I have limited that is 200 seconds. Okay, so 200 seconds stop. Okay, simulation time address, not second. That is 200 is the simulation time that place. Okay, so if I for uh, video point of view, I will just put it to the maximum iterations. So 5. So how it will run, you can check this one. Okay. So now I am putting in the control enter. So it will start running. So you can see this one. Here start parallel pooling operation is started that you can see. Parallel operation you can see here. So here parallel pool operation starting. So it will take time. It's depend upon the our RAM. Okay, so our RAM and how much RAM, like 8 GB, 6 GB, 12 GB, 32 GB. Okay, so based on that will the number of works. Okay, so my system is the 16 GB RAM. So that's why it's the 4 workers. If it is 32 GB RAM, it will show the one. Okay, so here it's showing that VCD FOBD has unsaved change because whatever there is there, so I'm running with the parallel. So here I have changed something. So if I saved means then only it will work. So now I am saving. So because I have changed the numerator values, okay, minimization, that's why it's marks. So after saving, it will be run. So let's check here. So we have saved our image. Okay. So after saving, okay, now it's saved. Now we will run the our part. So now we will control enter will do. So now it starts again. A live editor will start. So here is whatever the code is there. This is our code is there. So here in the cast function I will run at the end. Okay, most of the systems they will do the separate. Okay, so depend upon our so if you I am running at the live, so live editor, so you can also you can write it up or download utilize that mat file also you can take. Okay, so in this way we will do the then. So now I put the max iterations. Right? So let's see the how it will be run. So until it will run, so just we will go through the our code. Okay. So here I will have the code. So we can see the here this button. So parallel pool is running up. We can see here. Okay. So if it is parallel pull started, it will show the number of. So if it is parallel pull is not work means it will show here parallel pull is a shutdown is connected up. And another thing is that so in this one you can see the processor. Okay. So here if you go to here two column default. So here if you play the default. So three columns. So okay, we can see the history. So you want to close history we can place. So this is the file directory. You can also want to close. Then close. Upper band value will be different. So that you need to check. So that how you need to take that lower band upper band. It's depend upon the your transfer function. Okay. So it will be different. So maximum number of population max ventilation is also it's different. Okay, so code will be you can available in the MATLAB file exchange. You can download and cost function you need to write for your either using these. Uh, so here I am using the simple cost function. Okay, so that is I am using the this. Okay, so based upon I am using IAE, ITAE with some penalty. So you can also use the single okay single objective or double objective. Okay, in case if double objective or multi objective is there, so some people they like as single objective with the scale up or with some variable. Okay, that is also one of the possible. So depend upon our availability you can do this. So this is our what is that this is optimization practical. Okay, now we will go to this one. So we will now go to the dot. Okay, so I will dark here. So you can see the our open. Okay, so we will save. Now we will save this file. So this is our cast function. You can see. So this is the one our other way of saving. Okay, so in the, here you can see the you can download the any uh, algorithm files in the MATLAB file exchange. Okay, so but you need to write your own uh, cast function depend upon which uh, objective you want to do. Okay, ITAE, IAE, or error based or multi objective. Okay, so either frequency based or transient. Okay, time responsive that you need to choose for depend upon your desired response of your output. So these things you need to be careful while doing. So these are the things you need to care for optimization things. Now we will see the codes. Okay, so this is our code. What we require for optimization, we require the one is a step response, another the PI block, and here we are the transfer function. So I have taken the FOPD. Okay, first order plus dead time model. So here I have the input signal and output signal. So this is our control signal always. So here is the our error signal. So some people will directly from the error signal they will build the block. So IAE, ITAE block. But to uh, to reduce the running time, okay, so reduce the simulation running time, so have do the calculations in the past function only. Okay, that will be minimize our function. Okay, and if how much space is there, that will simulation also do the fast on that way. Okay, if you create the block here only means it will take the more amount of RAM. So that means your energy cost energy also it will be changed. Okay, that's why run the smooth limits for you need to do in the workflow only. So this is the one thing we can do. So this is the ARO block with the parallel code operation. Okay, so this code also available in the MATLAB file exchange. You can check and download and try for your own. So let's check how many people. So okay, anyway, we can try that one. So if anything have similar doubts, you can check and ask. So put your in the comment box. If it is based on availability, you will get the answer. Okay. So if any doubts are there, you can place and ask. So thank you. Have a nice day.